This is obviously an excuse to play around with microcontrollers. The heart of pretty much robots, projects, animatronics.
Every modern car, just about everything. Yeah.
So what's a controller do?
So, first of all, it's important to understand the difference between a microprocessor and a microcontroller. A microprocessor is strictly a chip that processes information. It's the main component of your PC. A microcontroller takes a microprocessor and adds several functions to it, such as memory as well as a controller functions. So for example, what Patrick's got here is the parallax microcontroller called the basic stamp. The basic stamp has the major feature on the bottom of a microprocessor. That's the SX microprocessor. It also has two other little microchips above that you can see. One of them is an EEPROM, which stores the program on that chip so you don't have to always be talking to a computer. And the other is the interpreter, which converts that stored program into machine language for the SX chip to run. In addition to the parallax basic stamp, there are thousands, if not millions, of different microcontrollers that you can buy. You can buy everything from what are called PICs, which are small single chips, such as we have here. This is a PIC. And we also have PIC burners. So the thing with a PIC is it's a very, very cheap microcontroller. You can buy a PIC for under $1, and they're very, very powerful. The problem is that you then have to buy a PIC burner, which can be several hundreds of dollars. So I brought in two different PIC burners, one of which is an older one, and yes, actually uses an RS-232 port up top. Oh, how ancient. And the newer version still actually uses serial for some reason that I can't explain. All too many burners still use serial or parallel rather than USB.
Because nobody's bothered to update them.
No one has bothered to update them. All the guys who are programming these are old Unix guys with authority bellies and really scraggly beards. And so you can buy a basic PIC burning kit for a couple of $100. Now, that may seem expensive, but if you're going to be making a whole bunch of things, then basically you have that initial cost of the PIC burner of, say, $100, $150. But then all of your actual microcontrollers might be as cheap as 80 cents.
So, you know, you're burning a PIC, are you putting in a board like this, or is it for a permanent installation? I mean, they're cheap, right?
They're dirt cheap. So a PIC is generally used for a permanent installation. That other board is something called a prototyping board. Now, what you've got now are two different boards. This is like your first version where you're just burning that at home of a permanent board where it would be permanently mounted. And the other one, the light green one, is the actual final version. So once you've figured out how to do it at home for your permanent board, then you send it off to Taiwan or wherever and have 1 million of them made. In this case, the two boards you're looking at are robot controller boards that my friend Jack Buffington and I came up with, specifically so that we could make cheap ones rather than more expensive ones.
Right. Because you said like these controllers are like $40 a pop. And PICs are $1?
Yeah, that particular PIC I think was $1.20 each.
Wow, that's a big price difference.
Yeah, the thing with something like either an Arduino, which is this one, or a basic stamp, such as that one, and there's others, you can buy basic X boards and J stamps and UU PICs and all sorts of other things, generally cost in the $20 to $40 neighborhood.
Right.
A general Arduino prototyping board, such as you've got there, the blue one, costs, I think, $25 off the top of my head. But again, it's a prototyping board. It's not really something that you want to put into major production. Well, the Systm crew really wanted something better than an LED, so that meant using a servo. And so we wanted like a little email flaggy flag thing. So that's what we're using today, is our email flaggy flag. I think that's the official term, is flaggy flag. Yeah. I'll have to call the post
Our mailbox
office.
flag, as
Our
it were.
mailbox flag. And
I'm
so
simulating the operation of the mailbox flag. See, in the reality, this will turn and not the entire servo itself. So, just pointing that out.
So in terms of the root program, it operates fundamentally the same as Jamie's original program that we can find online. Except for we're doing two different things. One, we're going to use a servo rather than an LED, and number two, I'm going to use the parallax board rather than the Arduino, not because of my great love of parallax boards, but out of sheer unadulterated laziness. Is the parallax development board has a servo attachment built into it, and the Arduino board does not have a servo adapter built into it, and I really didn't want to take out the soldering iron because the soldering fumes are killing me these days. Yeah, so the parallax board has 4 built-in servo adapters, and the Arduino board does not. So
1, 2.
There's nothing against the Arduino. I'm just saving a step in using the parallax board rather than the Arduino board. The code for the Arduino board will also be up available on the Systm website, so you can pick your code, which code you want to use, Arduino or the parallax board.
Was there some sort of heavy translation thing going on to get what was originally Arduino code to run on the stamp?
No, both codes, and this is actually kind of a good first project, both codes just wait for a serial character to come out of the computer,
right.
And so they're always listening. There's this little microcontroller ear going, hello, hello, and as soon as the computer sends out a signal and says, poof, and it sends out a character, that character is what, in the Arduino case, would turn on the LED, or in the parallax case, will open the servo.
Now, we should point out at this point, it could open a servo, you could use it to trigger a relay, you could use it to turn on a remote switch and turn on a lamp, you could use it to any of it. This is
big
basic
sound alarms, you could have a wah, 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 submarine
This
dive
is just
horn.
basic building steps you can use to use basically the fundamental code that would board inside of a controller to do something. Controllers do something. These are baby steps so you can do more interesting things with the controller. Not that our servo flag is not fascinating.
It's exactly, and it's an interesting thing of once you really start getting involved in microcontrollers, turning on an LED is basically sending current through that LED.
Right.
And as Patrick mentioned, you can also use that for a relay. And what a relay is, it's an electromagnetic device that closes when it feels current. And that connects another device. So you can actually use this tiny little amperage, which would normally turn on, say, an LED, to close a relay, and that relay then can carry AC current, for example. So you could turn on a light bulb, a regular old 110 volt AC light bulb, using a board like this by replacing the LED with a relay.
Cool. So we've got all of our hardware hooked up, right? We basically plugged the servo into the parallax board, into a USB serial adapter, into the computer. We need to have Python installed on a machine.
If you're unsure if you've got Python or not, you can go to python.org to download it, and that includes all of the different variants, whether you're running a Windows machine, a Linux machine, or a Mac machine, or a BSD machine. Most Macs with OS 10 have Python pre-installed.
It's down to the developers. That little developers folder you never go into, it's in there.
All sorts of weird stuff on computers that you don't know exist. Right. And now you just need to modify the Python script. And fortunately, the script, you don't have to worry about any coding. All you're modifying is you're putting in your username and password for your Gmail account and
saving it.
How
do I run it, though?
Now, depending on how your Python installation is configured, there's lots of different ways to run that. On a Windows machine, you can run it as a batch file under a shell script, so it's constantly running in the background. On a Macintosh, there's a plist file which we're going to make available for you, and basically that plist file will just run on boot, and so it'll automatically run that Python script as well.
So it's running on that OS 10 box right now?
It's running on this OS 10 box right now.
So if I send you
if you send me a Gmail account,
a message to your Gmail account,
an email to my Gmail account, what should happen is that once the speed of the internet has caught up to this machine and it has notified my Gmail account, we'll suddenly see that go up. And it's really that simple. It's not that we're leaving out any crucial components or anything like that. Anytime a software installation happens, you might have wonky little issues. The real issue here is basically trying to install something here. If you want to use an Arduino board, you're going to have to do a little bit of configuration to get a servo onto an Arduino board, because the ground and the power, which is what powers a servo, but is very different on the board from where the actual data port is. So you're going to have to either split up those wires or get an Arduino shield.
Okay, the test message is away.
So I'm going to turn on the board.